Good morning to all. I'm Smitra. Good morning to all. I'm Smitra, working as an associate professor in EEE department. And this semester, I'm handling microprocessor and microcontroller for third year EEE students. In this video, I'm going to explain about an IC 8255, which is meant for programmable peripheral interface. So now first, we need to know what is the necessity for going for this IC 8255. So it is nothing but an IC which is meant purely for increasing the peripheral handling capacity of any processor. It may be either an 8085 or 8086. So for example, if you are in need to interface many number of IO devices, which is not possible with the processor because the processor is said to have a limited number of IO ports. If you are in need to go for many number of interfacing devices, then obviously we need to select this IC 8255, which is used to enhance the peripheral interfacing capacity of any processor. How this can be achieved means first we need to know what are the specific features this IC is supposed to have. And this IC is nothing but an IO port, simply an IO port, right? Which is meant for interfacing number of IO devices with the processor, either a 8085 or an 8086 processor. How this can be done means with the this IC is having three ports, and the three ports is an 8-bit port which is having a capacity to act either as an input or output port by properly programming its mode of operation. And this type of IC is meant for implementing the parallel data transfer between the processor and the devices which is having a slow speed when compared to that of the processor. For example, the devices like ADC, DAC, keyboard, and 7-segment display. So now coming to the specific features of 8255 programmable peripheral interface, it is compatible to work with both the processor 8085 and 8086, and it is designed to increase the capacity of input-output interfacing. How this can be done with the help of the three 8-bit bidirectional IO ports, and also it is having different modes of operation like BSR mode and simple IO mode, handshaking IO mode, and bidirectional handshaking IO mode. Then features already I explained. It is having three different ports which are 8-bit wide. And then coming to the explanation how the IC 8255 is functioning in different modes as being programmed by the processor. So coming to the block diagram, it is having various blocks. Uh, Here on the right hand side, we have the port representation. As I mentioned earlier, this 8255 is said to have three different ports, namely port A, port B, and port C, where port A and port B are 8-bit bidirectional ports, and port C is divided into two groups, namely the port C upper and port C lower. So where the dif- different ports like port A, port B, and port C upper and port C lower are being controlled by two group controls, namely the group A control and group B control, where group A control is controlling over port A and port C upper, and whereas the group B control is controlling over port B and port C lower, right? So the controlling can be provided by means of the two different control groups. And apart from these blocks, we have an internal data bus through which we can interface with the processor system bus, and also the data bus buffer and the read-write control logic block, which involves the various control signals with which we can able to interface with the processor. So now let me explain about the blocks in detail. So coming to the data bus buffer, it is an 8-bit bidirectional data bus which is meant for interfacing the IC 8255 with the system data bus. And the internal data bus and its output pins, that is D0 to D7, are connected internally to the system data bus. And the direction of the flow, that is the communication of the data between the IC 8255 and the processor, is going to get decided only by the status of the read and the control logics. That is the status of the control signals which are present in the control block. The next one is the read-write control logic, and this logic block is getting its input from the control bus and the address bus, whereas the control signals are read bar and write bar, and the address signals are A0, A1, and CS bar. Apart from this, it is also having reset pin also, which is used to reset the entire operation of 8255. That is, the IC can be enabled or disabled by means of the reset along with the chip select signal. Next, coming to the group A and group B control. As I mentioned earlier, the group A and B get the control signal from the processor and send the appropriate command to the individual control blocks. So coming to the group A, it will send the control signal for port A and port C upper. So as I mentioned earlier, the controlling of the port A and the port C upper, that is from PC4 to PC7, is provided by means of group A control. Similarly, port B and port C lower, that is PC0 to PC3, is getting controlled by means of the group B. So coming to the individual ports operation or features of each and every port. Regarding port A, it is a bidirectional 8-bit buffered IO latch, and this port A is having a special feature or specific feature that it can be programmed in all three different possible modes of IO operation, like simple IO and IO with handshaking and bidirectional handshaking method, whereas the other port B and C is not having such a feature. And then coming to the port B, this is also having an 8-bit buffer IO latch, but it can be programmed only in mode 0 and mode 1. And coming to the port C, and this is also an 8-bit unlatched buffer, which means that doesn't have a latched input and output. And already we know that this is split into two parts by means of which we can programming it in a separate thing. And also this port C can be programmed only in the BSR mode, whereas port A and port B is having its capability to program in different modes of operation under IO, like simple IO and shaking IO, then bidirectional and shaking. Then coming to the pin details, it is again a 40-pin IC where the different ports, as I mentioned earlier, it is having three different ports like port A, port B, and port C upper and port C lower. And all the pins which are getting related to the ports are shown over here. And port A is from 1 to 4. Along with that, from pin number 37 to 40, it is getting related with port A. And then pin 5 and 6 is for read bar and chip select bar. And pin 36 is for write bar. And then similarly, port C is starting from 17 to, that is pin number 10 to 17 holds the port C signals. And similarly, port B signals are from 18 to 25. And port D signals are from 27, that is not port D, internal data bus signals, D0 to D7 is from 27 to 34. Along with that, we'll be having reset, VCC, and ground. So the explanations, the functions of the pins are given over here. The data bus pins, which are represented as D0 to D7, these are 8-bit bidirectional data buses, which are getting connected to either an 8085 or an 8085, just for mentioning the transferring of data. And chip select bar, that is CS bar, it is an active low signal, and only if this pin is enabled, then only the required IC can able to interface with that of the processor and read bar. And if this signal is active low, then the processor will read the status or data from a selected IO port of the 8255. And write bar, when this is active low, then the processor writes the data into the selected IO port. And then the address A0 and A1 is used to select the ports for required operation. Like similarly, if A0, A1, A0 is 00, it will select port A. And if A0, A1, A0 is 01, port B is being selected. And if it is 10, port C is getting selected. And if it is 11, control register is being selected. And then there exist different operating modes in 8255, which I will explain in my next video. Thank you all.